ahead, we will discuss on the proportional to absolute temperature. Proportional to absolute temperature refer to a type of temperature sensor or voltage reference where the output signal, typically voltage or current, is directly proportional to the absolute temperature measured in Kelvin. This property makes the circuit useful to the temperature sensing and compensation of. Then that means this output voltages or current directly proportional to temperature, directly proportional to temperatures. How it will work? It consists two transistor. So paired circuit be proportional to absolute temperature circuit, typically based on the behavior of bipolar junction transistor. The voltage differences between the two BJT operatings at different current densities produce a voltage that vary linearly with temperatures. Means this output differences even directly vary linearly with temperatures. That means the BJT output it operating the current density produce the voltage that with temperatures के साथ. The voltage directly proportional to the temperature temperatures. So the proportional to absolute temperature is directly proportional to temperature sensors like used in integrated circuit ICs. Temperature sensor like band gap is used to in ICs में. The applications of proportional to temperature in temperatures are used integrated circuits. Temperature sensors like band gap or references. Temperature compensation helps to stabilize the electronics component affected by temperature variation. Analog mixed circuit used the reference voltage ADC. Industrial and automotive electronics applied in industrial management system. Thermo EMF sensor. The thermo EMF electromagnetic force is a temperature sensor that generate a voltage when there is a temperature differences between the two junctions at different material. This phenomenon based on the Seebeck effect. Means voltage thermo EMF a thermo electromotive forces a temperature sensor that generate the voltage when there is a temperature difference between the two junctions. When temperature differences between the two junctions based on the Seebeck effect, which is that the voltage is produced in a circuit composed of the two dissimilar conductors when their junction are different temperatures. Thermometer sensor introduce electromotive force, a temperature sensor that generate the voltages. Means sensor is nothing but thermocouple. This means this is the thermocouple. This is the temperature T1. This is the hot temperature. This is the temperature T2. This is the cold temperature. That means temperature sensor that generate the voltage when when different difference two junctions T1 and T2 of different materials, material A, material B. So this phenomenon, so generated voltage directly proportional to temperature differences delta T. This is a T2 minus T1. So directly proportional to temperature T2 minus T1 gases EMF. Thermo EMF were widely used temperature measurement like thermocouple, electronic temperature compensation, industrial and scientific application. Type of thermo EMF. First, thermocouple, metal based thermocouple. The thermocouple are most common type of thermo EMF sensor consists two different metal wire. Only this only this whole are work on this like this. This is the thermocouple, two different metal A. This is the T2. This is the T1. So they consist of the two different material wires joined together, create a hot junction measure point and the cold junction reference point. The voltage generated directly proportional to temperature differences. So that's metal A, metal B, metal B. That output voltage is directly proportional to S into delta T. So different type of thermocouple we can see. Common type of thermocouple, K type thermocouple use the chromel aluminum. Generally temperature range is a minus 200 to 7 minus 200 to 30 degrees Celsius. This is J type. This is the sensitivity. That's like sensitivity S. When we discuss about the voltage V equal to any thermocouple equal to S into delta T, where is a delta T is a temperature differences between both junctions. uh, This this S is just Seebeck coefficient. That's why called sensitivity is different for it depend on the which type of semiconductor material is used. For K type semiconductor, when the chromel or aluminum are used, so that sensitivity S is approximately 40 microvolt per degree Celsius. That range of this thermocouple is minus 200 to 1300. J type, this iron constant J type generally used as a iron constant. That's the range minus 200 to 750, 750 or 60 degrees Celsius. It's sensitive. It's more it has more sensitivity. This is a range about 50. That's why generally the copper constant, this is the T type. The copper constant T type, this range is minus 400 to minus 200 to 400. This is lowest temperature range, but its sensitivity approximated 43. Next is a chromal aluminum E type. This range minus 207 to 1000. This is the highest sensitivity the E types and high. Next is the platinum rhodium. Its temperature range, highest temperature range 0 to 1600. Its sensitivity is very low. So highest sensitivity E type like chromal constant, and lowest sensitivity S type. Highest temperature range R or S type. So this is the based on semiconductor material. Next, semiconductor material based on the thermo EMF. These semiconductor material based on the thermo EMF. So this is a semiconductor material that's temperature sensors like. So what we have to learn in generally in this K type, the range general K type range is important. Range is like minus 200 to 1332 1372 डिग्री. जिस जनरली के टाइप में chromel or aluminum are used. Generally, chromel and or aluminum are used. So this table you have to memorize. Generally, This is the important is the K-type semiconductor generally most used. J-type semiconductor is the more important. T-type this is the lowest temperature ranges. E-type is the highest sensitivity. They will ask the question which have the highest sensitivity. Answer is a E-type semiconductor, which has highest temperature range. R or S-type thermocouple, which has more linear behavior. This is a more linear behavior like J-type thermocouple. This is generally less cost or generally used in industry. K-type thermocouples. This based on this question they will ask in different exams. So generally you have to learn about the highest sensitivity this, highest temperature range this semiconductor platinum rhodium, most used industry. This is the most used industry, most used in industry, most used in industry. Industry, most used in industry. Most used in industry. Iron Constantan. Lowest sensitivity. This you have to know highest sensitivity. In this way, they can ask the question. D is a semiconductor based thermal EMF. These sensors are used temperature dependent behaviors of semiconductor to measure temperature. Unlike metal based thermocouples, in thermocouple, semiconductor sensor operated based on the PN junction diode. Type of semiconductor based on thermo EMF. Semiconductor sensor operated based on the PN junction means the sensor use temperature dependent behavior semiconductor to measure the temperature differences like metal based thermocouple semiconductor sensor that operate based on the PN junctions. Type of semiconductor based on the thermo EMF. First is the junction semiconductor ICs, that's LM35 IC. This is the LM35 ICs. This is the LM35 ICs. Its specifications. This is the LM3. Has three pins. First is a VCC pin. Its temperature range is VCC is this is the VCC pin. VCC pin. This is the ground pin, and this is the its output pins. This is the output pin, analog output. What is the ground pin? Ground is a power supply pin that LM temperature sensor IC that can be connected up to 4 or 32 volt supply. 4 or 32 volt, 4 volt or 30 volt supply. This is the VCC. This is the VCC. We can provide it 4 volt or 30 volt this supply. Second is a ground supply. The second is a ground pin of 30 temperature sensor that should be kept to grounded. Output this that is a temperature sensor analog output. It provided the analog output. This analog output pins temperature sensor. How does it work? When it's temperature, this is the temperature ICs. We provide 5 volt analog. One is grounded, and we take the input and we take the output between the ground and analog output. So the how the B output is calculated here. B output can be calculated. This is divided by the temperature. Suppose that this is a thermometer measuring the room temperature. We want to change this temperature in terms of electrical voltages. So this is the temperature is 80 degree. This is temperature is 80 degree divided by 100. We have if when we provided the 5 volt power supply by 100 equal to output is 1.8. Next, if this thermo indicated 20 degree, if this thermometer right now is indicating 20 degree, suppose that's the 20 degree, then we can write the output equal to 20 upon 100. This is the 20 upon 100 is right. That time voltage is 0.2 volt. This is the next. Suppose that right now temperature is indicated like, suppose that 35 degree Celsius. Suppose that any temperature right now indicate 35 degree Celsius. So then we can write the output of the system 35 divided by 100 equal to 0.35. 35 divided 0.35. In this way, each temperature changes, the output of this IC changes. So this is the type of semiconductor based on thermo EMF junction type semiconductor use LM35 ICs. Mm, Second is a proportional to absolute temperature. This another circuit. This is the, for examples, temperature proportional to absolute temperature. And this is the IC. This IC change the voltage to this sensor that change the absolute temperature to AB to output voltage. Absolute temperature to output voltage. So suppose that this is the air temperature something like this, then create the voltages, and that voltage is shown here in terms of some voltages. And this also I see that again that shows the voltage here, and give the provided that here and here. Based on this, output can be written based on this to these are the proportional to absolute temperature devices. Then its output can be written V0 is nothing but temperature differences T1 minus T2, T1 minus T2 into 10 millivolt per degree Celsius, using this 10 millivolt per degree Celsius. Based on this, if suppose that T1 is 50 and T2 is 60, so differences is just 10 into 100 millivolt per second output. In this way, this port can be used. The circuit of demonstrate karta the one method which differential temperature measurement can be made by R1 and R2 can be trimmed output. If R1, this is the R1 and this is the R1 and R2. This is the R1 and this is the R2 can trim the voltage. Suppose that trim means, suppose some voltage like here. If we want to trim this voltage, suppose that this is the trimmed voltage like this. This is the trimmed. We can remove some part, can changes. That trimming is done by the R1 and R2 used to trim the output voltage to indicate a desired temperature difference. For example, inherent offset temperature between the devices can be trimmed if V1 positive and negative are radically differences. Then difference of internal dissipation called differential internal temperature rises. So this effect used to measure the ambient thermal resistance can be seen that temperature approximately 30. Suppose that if, for example, if inherent offset means some inherent bits. This is the ICs. This is suppose that is op-amp IC. It's even provided some output. Even both input are zeros. Even both input are zero provided some output. So such type of output are called it inherent output because of it there's so many active components are used like that. Because of that active components, this is a provided inherent unusual unwanted output. That's called it inherent offset of devices can be trimmed using the R1 and R2. If the V positive and negative are radical differences, suppose that V positive is 15 or V negative is minus, suppose that minus 10, like this. V positive are radical difference, then difference in internal dissipation causes to differential temperature rises. Because of this internal differential temperature of this device can be also raised. So this effect can be used to measure the ambient thermal resistance seen by the sensor and dissipation applications such as fluid level detector or anemometry. Thermoelectric power. Those are thermoelectric power, the Seebeck coefficient. Thermoelectric power or Seebeck coefficient S is the rate change of thermo EMF. Suppose that this is the rate change of the rate change, मतलब change in output voltages delta V. Sometime we can write the delta V, change in output voltage or change in temperatures. This is the change in output voltages, input voltages. This is nothing but sensitivity by change in output by change in input. So that's in terms of thermoelectric power, that this is called the Seebeck coefficient. Seebeck coefficient is nothing but sensitivity. So this the rate change of thermo EMF voltage with respect to temperatures. So this is the change in output by change in input, the ratio change in. So change in output nothing but change in voltages, change in input nothing but it is a temperature. So that's why it is a sensitivity. Where is we can see the S unit is the microvolt per Kelvin, B is a thermo EMF or voltages in millivolt, T is temperature. Each material combination has unique CVAC because we have just discussed thermocouple. Different combination J type have different sensitivity, K type have different sensitivity, S type have different sensitivity, T type have different sensitivity. So that's it. This is nothing but sensitivity or CVAC coefficient different for different type of semi material used in that sensors or thermocouple. Factor. Second is a factor. Second is each material combination has unique Seebeck effect. Higher Seebeck effect, the larger voltage generated per degree change in temperature. So we can see the change higher delta V by delta T. If S is high, if this is S is high, then V0 also high. If S is low, then V0 will be low. So based on this, the factoring temperature, दूसरा material property like electronic structure, thermal conductivity, temperature ranges, some material degree. Material based on the material, sensitivity can be changed, conductivity change, sensitivity can change, temperature ranges, different material had different temperature range. Environmental factor, humidity, oxidation, different material have different oxidation capacity or reactiveness. So this type of material we have used to making the thermocouple, that material is decided the sensitivity and thermo and other comparison. So general consideration for thermo EMF is when designing or selection a thermo EMF sensor, several factors should be considered. So, like for material selection, thermocouple use two dissimilar metals. So when this is the thermocouple A and thermocouple B, we have to use different material metal A and metal B. This is the two metal A and B. Two this create a temperature difference voltages. How they how they create the voltage? Voltage V is nothing but as sensitivity into delta T. T is nothing but temperature differences T1 into T2. The calibration and the thermocouple required cold junction compensation to correct the reference temperature. Semiconductor sensor offer higher accuracy due to precise calibration. So this do, so two dissimilar matter. तो material selection two dissimilar metal use करते हैं. Otherwise if we are not using two dissimilar metals, then output must be zero. Look, output for semiconductor sensors, silicon based PN junction voltage variation we can use. Calibration and accuracy. Thermocouple require cold junction compensation to correct the reference output. For cold junction compensation required to semiconductor offer higher accuracy due to IC precision. Semiconductor, that's why semiconductor be generally compensation and calibration is a noise and stability. The metal thermocouple can suffer from the signal drift over time. Semiconductor sensor provide more stable output, have different temperature limits. So we can comparison like this, which this is not thermocouple use voltage range microvolt. The IC like LM35 or other TM36 RLC, this is a linear and voltage range is a millivolt range. AC is good change of voltage because its voltage is proportional to absolute temperature sensor 859. This current output is microampere is outputs. The accuracy plus minus 1 to 5 degree, that says IC sensor LM35 plus minus 1. So highest accuracy is LM35 because it's this accuracy in terms of error which is minimum, that's a more accurate. Temperature ranges thermocouple is minus 270 to 1600 degrees, the highest temperature, and IC generally used like minus 50 degree to 150 degree. PAT generally used to absolute PTAT, absolute temperature proportional to absolute temperature is generally minus 50 to 100 degrees Celsius. That's why this is the base of these devices are based on the semiconductor material. That's why these temperature ranges is very small. But thermocouple have highest temperature ranges, but LM35 have more accurate accuracy terms. We need to this, and when we need to output in like of millivolt ranges, that's why generally IC 35. So this class will next class we will discuss about the semiconductor type.